Hello guys, after box introduction on math, we are going to introduce Simulink based on the definition that we have here. Simulink is a toolbox or toolkit or software package available in MATLAB software for modeling, simulating, and analyzing dynamic systems through graphic design. Actually, the most difference between Simulink and MATLAB is that the Simulink uses graphical design in order to simulate rather than using codes. It means that there are some blocks and graphical tools available in order to simulate. The basis of Simulink in MATLAB, you define the code directly, but in Simulink you organize the blocks, and the Simulink software turn it to the code. Means the most important feature is the full compatibility and connectivity to MATLAB programming language and other software packages and MATLAB based toolbox. It means that in any project that you want to do, you should make sure that you have that particular block or graphical tool in the software in order to simulation. But if there was not such blocks or graphical tools, you can define your own codes in the Simulink and then use that codes in Simulink and connect it to other existing blocks. Considering the above feature, even if it is not possible to simulate a special system in Simulink, it will be possible to create and simulate it due to the power of MATLAB programming. Based on these features on Simulink, as you know, people are not interested to deal with codes and such things. So it can be said that MATLAB software owes much of its reputation to Simulink in the MATLAB. Most important applications of Simulink are here. You can see them, but there are much more applications that I brought here. Some of them, for example, here in the first one, we have implement and simulate static systems. These systems will be explained later. And then we have implement dynamic models using common and base block sets, and then simulation, analysis, and implementation of control systems, which are common among electrical engineers. And we have simulation of electrical systems in the form of physical models, simulation of electrical, then we have simulation of electronic circuits and high frequency circuits. We have simulation of power systems and electric machines. We have simulation of mechanical systems in the form of physical models. We have simulation of electromechanical systems in the form of physical models, and there are some other features. Also, in this file, we are going to have introduction on the most important applications of Simulink. Here, as you can see, there are examples of simulated systems in Simulink. As you know, here we have dynamic system of a 14 jet completely, which is a prepared model. Then here we have a wind turbine that completely modeled here. Here is the motor of the turbine. Here we have wind copper generator and some other parts of the wind turbine. Based on this, you can have general overview on the power of Simulink in the simulation of dynamic systems.